In this video, we are going to learn how to multiply matrices. Let's say we have given A is equal to 3, 2, minus 1 and B is equal to 4, minus 7, 3, 6, 5 and minus 2. Now we are going to multiply A by B. So how can we multiply matrix A by matrix B? Now let us first talk about the order of the matrices. The order of the first matrix is 1 by 3, that is it has got 1 row and 3 column, and the order of the second matrix is 3 by 2. It means that matrix B has 3 rows and 2 columns. When we multiply two matrices, number of columns in first matrix should be equal to the number of rows in the second matrix. So in this case, the matrix A has 3 columns and matrix B has 2 columns. It means that here we can multiply these two matrices. Now, what is the meaning of these two numbers? What do they tell us? They tell us about the order of the product matrix. The resultant matrix, when we multiply A by B, the order of the resultant matrix will be 1 by 2. It means that the resultant matrix will have 1 row and 2 columns. So let us multiply A by B. The product matrix will be like this: A11, A12. It will have 1 row and 2 columns. So A11 will be given by A11 means we have to take the first row of the first matrix and first column of the second matrix and will multiply the corresponding elements and will add them. So A11 will be 3 into 4 plus 2 into 3 plus minus 1 into 5, that is 3 into 4, this 3 will multiply this 4, 2 into 3 and minus 1 into 5. So the sum will be 12 plus 6 plus minus 5 equal to 13. It will be 13. Now A12 will be, now we will multiply the first row. Row will come from the matrix A and columns will come from the matrix B. We will multiply first row of matrix A with the second column of the matrix B. So the result will be 3 into minus 7 plus 2 into 6 minus 1 into minus 2. The result will be minus 21 plus 12 plus 2 is equal to minus 7. So the resultant matrix will be, the product of A and B will be 13 minus 7. The order of this matrix will be 1 by 2. The order of matrix A was 1 by 3 and the order of matrix B was 3 by 2. So the resultant matrix will be of order 1 by 2. The product matrix is 13 minus 7. Let us revisit our matrix once again. A was 3, 2, minus 1 and B was 4, minus 7, 3, 6, 5, minus 2. and the order of matrix A was 1 by 3 and the order of matrix B was 3 by 2. Can we multiply B with A now? Let us see. The order of matrix B is 3 by 2 and the order of matrix A is 3 by 1. Now the number of columns in matrix A are 2 and the number of rows in matrix A are 3. So this 2 is not equal to 3. So in this case we cannot find B multiplied by A. So the product of two matrices A and B will be defined only when number of columns in A equal to number of rows in B. Now think of a situation when both AB and B are defined for two given matrices. Yes, both matrices should be square matrices of the same order. Now let's check when AB and BA are defined. If AB is equal to BA, let A is equal to say 1, 2, 3, 4 and B is equal to 5, 6, 7, 8. So AB will be equal to 5 plus 14, 6 plus 16, 15 plus 28, 18 plus 4 is 32, and it will be equal to 19, 22, 33, 43 and 40, 50. Now let us find BA. BA will be equal to 5, 6, 7, 8. A was 1, 2, 3, 4. So this product will be 5 plus 18, 10 plus 24, 7 plus 24, 14 plus 32, is equal to 23, 34, 31, 46. This is the value of BA, and AB is this. AB is 19, 22, 43, 50 and BA is 23, 34, 31, 46. So obviously AB is not equal to BA. In most of the cases, when AB is defined, BA may not be defined. When AB and BA both are defined, both the product may not be equal. Now we know that for two real numbers, if AB is equal to 0, it implies either A is equal to 0 or B is equal to 0. But this is not true for matrices. If A is equal to 0, -1, 0, 2 and B is equal to 3, 5, 0, 0, 0, 0. So AB is equal to 0, 0, 0, 0. You can check yourself. Now clearly AB is a 0 matrix, but it does not imply A equal to 0 or B is equal to 0. Now some properties of matrix multiplication. First one is associative law. Associative law is AB multiplied by C is equal to A multiplied by B, C. It means that if you have to multiply three matrices, you can multiply them in any order. Second property is distributive property or distributive law. Distributive law. Part 1. Left distributive property. A times B plus C is equal to AB plus AC. Right distributive law. A plus B times C is equal to AC plus BC. Third one is existence of identity. For every square matrix A, there exists an identity element I of the same order such that AI is equal to IA is equal to A. The matrix A should be a square matrix. So this much only in this video. In our next video, we'll learn about the transpose of a matrix, symmetric and skew-symmetric matrices, and the properties of transpose matrix. Until then, keep learning. Thank you.